Number 24 in sample exam 2 is kind of one of these weird geometric setup problems right here. They've got, let's see, a line tangent that's to this graph right here, y is equal to e to the 2 minus x, which is a function we're probably not super familiar with, but the good news I think here is, everybody, I don't think we actually have to know what that function looks like. They tell you a point that it passes through, and that's your point of tangency. That's one of the things we're going to need. And the tangent line here, it says, intersects both of the coordinate axes, the x-axis and the y-axis, which means it has to be a diagonal line. They want to know the area of the triangle formed by this tangent line and the coordinate axis. So without getting too in-depth, the graph of this thing, everybody, you might recognize and you might not. I don't think it matters, though, like I said. The point 1e, I'm just going to kind of eyeball this right here. They're telling you that's the point of tangency. So clearly, that point is in the first quadrant. What else do we have going on? If we're talking about a tangent, I think we probably want to find our derivative right here. So that's going to be dy dx is equal to, the derivative of e to a power is the same base, e, to the same power, 2 minus x, times the derivative of that exponent, which is just negative 1. So I'm just going to put a negative out in front, and that's our derivative. And now, if we took dy dx and evaluated it at the spot right here at 1e, where x is equal to 1, that gives us a slope of the opposite of e to the 2 minus 1, which is, the first power. That's the slope of your tangent right there, negative e. Now, all that tells me, everybody, let's think about this one for a second now, is that I think we know already. Let's take a look. The slope of this line is definitely going to be negative. I think it's probably going to look something like this. And actually, something cool happens if you go a little further. We know the slope of our tangent. We know the point of our tangency. So let me switch to purple here. I'm going to find the equation of this tangent line. Y minus your y-coordinate, which is e, equals the slope of your tangent, negative e, times x minus 1. Let's solve that for y. Y minus e is going to equal a negative e times x plus e. Add that e to the other side, and we're going to get y equals negative e times x plus a 2e. Now, what's the significance of that? This y-intercept right here is the value 2e. So we're at the point 0, 2e there, and if we think about our slope here, guys, we've gone from 2e, our y-coordinate, down to 1e right over here. So our slope is down e and 1 to the right. That's kind of what this slope right here tells me. And if I repeat that, I didn't draw this great, but down e and 1 to the right, that tells us that this x-intercept right here is at the point 2, 0. Our x-intercept is 2. Now, if I go back, and I think I have a good sense of what's happening right here, they wanted the area of this triangle that was formed between the tangent line and the x-axis. So, area of a triangle is 1/2 times your base times your height. So for us here, that's going to be 1/2 times a base right here of 2, and then a height over here on the left-hand side of 2e. So the 1/2 and the 2 just cancel each other out, and we're going to end up with 2e square units for the area of that. Looks like our answer for number 24 is going to be A.